to Admire Engineers. I am Bipin. Here I am going to take the classification of signals part 2. In the previous video, I had already explained the types of signals, that is the periodic signal, even and odd signal, causal and non-causal signal. All these are important for the exams. Today I am going for the second part of the signal. Also, in this video, I will discuss some of the previous year questions from the GATE exams. So watch till the end of the video. Now, the next type of signal is deterministic and non-deterministic signal. A signal is said to be deterministic when it can be represented in the mathematical form. Such kind of signals are called deterministic signals, and the signals which is uncertain about the instant of time and cannot be represented mathematically. That means we cannot show a mathematical expression for a signal. Such kind of signals are known as non-deterministic signals, and it is also known as random signals. X of t is equal to, for example, sine omega t is an example for deterministic signal, because this type of signal can be represented in a mathematical equation. But some of the signals which we see in the CRO as noise, which cannot be represented as mathematical equation, such kind of signal are known as random signals. Another important classification of signal is energy and power signal. As we know, all the signals are basically a wide variety of phenomena or physical quantity. We can represent all the most of the properties of a physical system to a signal. If we consider, for example, if we consider V of t and I of t as the voltage and current across a resistor respectively, R is the resistor, then we can give the power dissipated as P is equal to V of t into I of t, which is equal to 1 by R into V square of t. So here we can write power P is equal to 1 by R into V square of t. Equation, the energy expended over time t1 less than equal to t less than equal to t2 is given by integral t1 to t2 P of t is equal to integral t1 to t2 1 by R V square of t. It will be the energy of across this resistance. And similarly, the average power over this period t1 to t2 can be given as P is equal to 1 by t2 minus t1 integral over t1 to t2 P of t, which is equal to 1 by t2 minus t1 integral t1 to t2 1 by R V square of t. So this will be the average power across a resistance, and this will be the energy extended over the time period t1 to t2. Then if we consider the resistance R is equal to 1 ohm, then energy becomes integral t1 to t2 V square of t dt, and the average power becomes P is equal to 1 by t2 minus t1 integral t1 to t2 V square of t dt. As here we had considered a resistance and the corresponding voltage and the current across it. It will be similar for all the signals. As signal is a physical phenomena, it will be it will share the properties of all the physical system. So in general, for a signal, if we consider a signal x of t, we can say the energy of the signal x of t is equal to integral uh, for a period minus t to t x square of t dt. But here maybe the signal, most of the signals are complex, so we cannot do this kind of squares and consider this kind of operations on the signal. So for generally when we are considering a signal, we have to find the magnitude of the signal. So we can rewrite this as E is equal to integral minus t1 to t minus t to t modulus of x of t square dt. And if we consider the time period goes from minus infinity to less than equal to t less than equal to infinity, then again the energy E becomes E is equal to limit capital T tends to infinity integral minus t to t x of t square dt. So we get energy is equal to uh, limit t tends to infinity integral minus t to t x modulus of x of t square dt, which can be rewritten as integral minus infinity to infinity modulus of x of t square dt. This will be the equation for energy of a signal in general. Integral minus infinity to infinity modulus of x of t square dt. Now when considering the power of a signal, power is always given in its average value. So P is equal to 1 by 2t integral minus t to t modulus of x of t square dt. It shows 2t shows the time period from minus t to t, and here also if we extend the time period from minus infinity less than equal to t less than equal to infinity, then p becomes p is equal to limit t tends to infinity 1 by 2t integral minus t to t modulus of x of t square dt. This is the average power of a signal in general. Average power of a signal in general. Also you should remember that the energy I had written earlier and the power equation just shown now is for the continuous time signal. Similarly, for a discrete time signal, uh, energy can be given by E is equal to sigma n is equal to minus infinity to infinity modulus of x of n square. It has also the representation like this: limit n tends to uh, infinity sigma n is equal to minus n to n x of n modulus square. Here the time period comes from minus n to n. So this is the equation of energy in general for every discrete time signal. And considering the power, P is equal to similarly limit n tends to infinity 1 by 2n plus 1, which shows the time period sigma n is equal to minus n to n x of n modulus square. So in general we can say for continuous time signal we have energy is equal to limit t tends to infinity integral minus t to t modulus of x of t square dt and power limit t tends to infinity 1 by 2 t integral minus t to t modulus of x of t square dt. And for discrete time signal the energy is equal to limit n tends to infinity limit n is equal to minus n to n, which shows the period, x of n square modulus of x of n square, and power is given by limit n tends to infinity 1 by 2n plus 1 sigma n is equal to minus n to n modulus of x of n square. And you have to note down these four equations, because it's very important for the exam. And in general here a surprising thing is that for finding the power in the power equation we can see that there is it is finding the mean square value of the signal. Here also the mean square value of the signal, mean of every signal. So by finding the root of the result we can find the RMS value, that is the root mean square value. So sometimes the question may be asked like that, a signal must be given and question must be asked like find the root mean square of the signal. So first of all you have to find the power of the signal, then find the root of the result. So here it gives two types of signals, that means the energy signal and power signal. In energy signal, when we find the energy of a signal, it will be finite. That means E, the energy of the signal, will be finite, 0 less than equal to E less than 0 less than E less than infinity. That means energy will be finite, and this gives the power is equal to 0. And the signal that satisfy this condition is known as energy signals. And in power signals the condition is power must be finite, and that gives the energy infinity value. This condition is for power signal. In your university question, the question will be asked like that: determine whether the given signal is energy signal or power signal. So first you have to find the energy, then power, then verify these conditions and give as energy signal or power signal. Sometimes we had also questions which comes under category neither energy nor power signal, which does not satisfies both these conditions. Such type of signal comes under this category, neither energy nor power signal. Now we are going to discuss about some of the previous year GATE questions. This question has been asked on GATE 2014. A discrete time signal x of n is equal to sine pi square n, where n being an integer, is these four options are given: periodic with period pi, periodic with period pi square, periodic with period pi by 2, and not periodic. Already we had seen in the previous video, this question comes under periodic and aperiodic signal, which have the condition x of n is equal to x of n plus capital N. If a signal satisfies this condition, then the signal is said to be periodic. So we had the given signal x of n is equal to sine pi square of n. So we have to find x square of x of n plus n. So then if we get the same x of n, then the signal will be periodic, and then we have to find the period. So then x of n plus capital N gives sine pi square. In the place of n it comes n plus capital N, which is equal to sine pi square n plus pi square capital N. So here sine pi square n plus pi square capital N becomes sine pi square small n only if when the pi square n is equal to 2 pi. Here pi square is omega, and the condition is pi square n is equal to 2 pi. Therefore from this we can find that capital N is equal to 2 pi by pi square, which is equal to 2 by pi. In the last video itself I had said that for all the values it will be the multiple of 2 pi, so m also comes here. In the last video I had said that the value of capital N and this small n should be an integer. It should not be an irrational number. Since pi is an irrational number, n is not integer, so it could not be considered as periodic. So it is not periodic or aperiodic. So here we have the answer with option D for this question. This is another question that asked in GATE 2013, that for a periodic signal V of t, 30 sine 100t plus 10 cos 300t plus 6 sine 500t plus pi by 4, the fundamental frequency in rad per second is 100, 300, 500 and 1500. For finding the fundamental frequency, the signal should be periodic. The signal, you have to find the fundamental frequency. For finding the fundamental frequency, here we have the signal is a combination of three signals. 30 sine 100t is one signal, 10 cos 300t is one signal, and 6 sine 500t plus pi by 4 is another signal. So here for finding the fundamental frequency, we have to find the GCD, greatest common divisor, GCD of, as the fundamental frequency is asked in radian per second, GCD should be of omega. So here we had omega 1 is equal to 100, omega 2 is equal to 300, and omega 3 is equal to 500. So when we find the GCD of these three frequencies, we will get a greatest common divisor, and that will be the fundamental frequency of the above signal. So when for finding the GCD of the signal, the factors of 100 is 2 into factors of 100 is 2 comma 2 comma 5 comma 5, and for 300 it is 2 comma 2 comma 5 comma 5 comma 3, and for 500 it is 2 comma 2 comma 5 comma 5 comma 5. And for this we have the common factors as here 2 comma 2 is common factor, then we see 5 comma 5 is common factor. So the GCD is equal to 2 into 2 into 5 into 5. What we will get, 2 into 2 4, 20, which is 100 rad per second. So we have the fundamental frequency, that is option A, it is 100 rad per second. So this is a periodic signal, and we have the fundamental frequency 100 rad per second. So that's all for today. Stay tuned with my channel for these kind of videos based on the engineering lectures. Thank you.